class, the first thing you need to do is you need to go to a+students.com. You need to go to the website. Once you're on the website, you need to select math as your subject. This is a grade 10 lesson, grade 10s. Okay, and the topic for today is algebra. And we are going to review algebra. We'll recall the name of the chapter number, and the lesson. Chapter number is 1 and the lesson number is 4. Chapter number 1, lesson number 4. Okay, and the name of the chapter lesson is simplify radical expressions. Okay, let's see what radicals are. Let's go to grade 10 maths and algebra. Chapter 1, lesson number 4. What are radicals? Radicals are also known as surds. Radicals are non-perfect square numbers. Okay, so let's see. If we say a square root of 16, right? A square root of 16 can be written as, we find the prime factors. We need to find the prime factors first for 16. 16 can be divided by 2, that is 8 times 2. This is 4 times 2. This is 2, 2 and 1. We know that now 16 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2. Agreed? So when we apply a radical on 16, we look at pairs. We have a pair of 2, the 2 comes out. We have another pair of 2, the 2 comes out. That means 2 times 2, the square root of 16 would be a 4. Agreed? This is something we know. Like we know directly that square root of 16 is always a 4. But what if we need to find a square root of a radical of 18? Let's try to find the prime factors. The prime factors for 18 would be 18 can be divided by 2. This becomes a 9. The 9 cannot be divided by 2, but it can be divided by 3. 3 and 3 divided by 1. So can we say 18 should be equals to 2 multiplied by 3 multiplied by 3. And when we apply square root on either sides, or we apply a radical on either sides, let's look for the pairs. Can we see we have one pair of 3's over here? So we can say 3. We do not have a pair for 2, so we can write 3 root 2. Agreed? That means under root 18 would be equals to 3 radical 2, right? We also know that if we have the variables, okay, I'll just put it in a box so that the information does not, okay. If I would say, if I was adding 3x is added to 2x, right? Can I say if I add 3x is added to 2x, we know that when the variable is same, okay, then what we can do is we can simply add the coefficients. 3 plus 2 would be 3 plus 2 would be 5. The same rule applies for radicals, okay? So if I would say 3 square root of 2 is added to 2 radical of 2, right? We consider the radical as the same variable. That means root 2 stays as the common, and 3 plus 2 would be, what is 3 plus 2? In this case, 3 plus 2 comes out to be 5. Okay, this is known as the distributive property. Okay, what we can do is either we can do this way, or what we could have done was we can take a common over here. Out of these values, we can take radical 2 as a common, and what would we be left with? We would be left with 3 plus 2. And finally, we can say this comes out to be 5 root 2 as well. So either ways, we have the same answer, right? By considering radical 2 as a variable, or by taking a common, we get the same answer. This property is known as distributive, right? Distributive property. Where we would take a common is a distributive property, or otherwise we can do it directly. Any number that is not a perfect square number would be a radical number. Okay, so let's try with the first question. Irrespective of addition or subtraction in the middle. Okay, radicals would always be formed by a prime number. Okay, it has to be a prime number. For this question, right, they're asking us subtract and write your answer in the simplest form. If we consider question number 1, can we say root radical of 7? 7 is a prime number, right? That means it cannot be further broken down. So if we apply the distributive property, can we take radical 7 as a common? If we take radical 7 common, then what we can do is we can subtract the remaining numbers, right? That would be 5 minus 6. And we know that this is the distributive property. And we know that whenever we subtract two numbers, since 5 is a smaller number than 6, we cannot subtract 6 from 5. But 6 minus 5 would be 1. And the sign of the larger number comes over here. That means our final answer is minus 1 root radical 7 is the final answer. Okay, do we agree? Okay, good. Let's move ahead. Let's have a look at another question. What we are doing here is just for now addition and subtraction. Okay. For the next question, I'll just copy the question. The question number 2 states that for this question number 2, the question says, and I'll just copy the opening statement. Subtract and give your answer in the simplest form for question number 2. Hi, Rebecca. This is grade 10. Okay. See, what we can see over here is if we have a radical. Radical is a square root number, okay, which has a prime number in it, under root with a prime number. So what we can say is this was minus 6 radical 2, and this was negative 3 radical 2. So what we can do is we can take 2 radical 2 as a common, and what would be left? We can say minus 6 and minus 3. If radical 2 is there, when we know the rule that whenever we have two numbers and both of these two numbers are negative numbers, a negative number added to a negative number would always give We do addition. When both the signs are same, when they have the same sign, we add them together. And we know that 6 plus 3 is 9. And we take the sign of the larger number, that is -9. Therefore, we can say the answer is -9 radical 2. This is the answer. Okay, agreed? Okay, moving ahead with the next question. Question number 3. In question number 3, they're asking us to simplify. Okay, this is a different type of a question. Let's see how we can simplify. Okay, whenever we need to simplify a radical that is not a prime number, right? The definition of a prime number is a number that cannot be further broken down. It comes in its own table and in the table of 1. Agreed? So if the question says radical of 490, so the first thing we need to do is we need to find the prime factors of 490. How do we find the prime factors? We can write 490. Since this is an even number, it can be divided by 2. 400, that would be 245, right? 245 comes as the answer. Can we further divided this? This cannot be divided by 2. This cannot be divided by 3. This can be divided by 5. When 245 is divided by 5, 245 divided by 5, it comes out to be 49. And we know that 49 cannot be divided by 2, neither by 3, nor 4, 5, 6, but by 7. So we can say 7 times 7 is 49, and 7 times 1 is this. So for the given question, we can say 490 can be written as 2 multiplied by 5 multiplied by 7 multiplied by 7, right? This is prime factorization. This is prime factorization. We found the prime factors, prime factorization. Okay, so once we have found these values, what we can say is, once we have the prime factors, we apply the radical on either sides. Can we find a pair of similar numbers? Yes, we can find a pair of similar numbers, and that pair would be 7, right? So whenever we have a pair, we take out the pair as an individual number. We take out 7 because we have a pair. And what is left inside of the radical? 2 multiplied by 5. Since 2 and 5 do not have pairs, they stay inside. And this becomes 7 radical. What is 2 multiplied by 5? That is 10. And 7 radical 10 will have the same answer as radical 490. So this is our final answer. Agreed? If we have a pair of numbers, similar numbers in pairs, that pair comes out as a single number outside, okay? 7 root 10. Let's move ahead to the next question. The next question says, okay, simplify. For the next question, again, question number 4. It says simplify, but this time the question has a variable in it. Okay, the question number 4 has a variable, and it says, let me just copy this. The variable inside the radical is 63 w square, right? Okay, the first thing first, the number that we have inside the radical, can this be written as radical 63 is multiplied by radical w squared? Okay, For 63, we need to do the prime factorization. 63 is not an even number, therefore it cannot be divided by 2, right? But let's see if it can be divided by 3. 3 times 21 is 63. 21 is not an even number, therefore it cannot be divided by 2. Let's see if it can be divided by 3. 3 times 7. And we know that 7 times 1. So in place of 63, can we write 3 times 3 times 7, which was to be multiplied by radical of w squared. So a w squared means w times w, right? So let's look at for pairs. Let's look out for pairs. Can we see a pair of 3 over here? Yes, we can see a pair of 3. If we have a pair of 3, the 3 comes out. Whichever number doesn't have a pair stays in. Looking at the value of w, do we have a pair over here? Yes, we have a pair. The pair comes out. And finally, we can say the answer is 3w root 7. Okay? Right? Because 3 and w were the numbers. They were whole numbers. They were outside the radical. So we write them together and the radical stays over here. And this is the final answer. Okay? Okay. Moving ahead, let's have a look at the next question. The next question says we need to add the radicals together and we need to write them in the simplest form. Let's see what is the rule. For question number 5, I'll just give an example as well so that we have a better idea. If this is the question given to us and they're asking us add them and write them in the simplest form for question number 5. If I would say minus 7x plus 4y, in place of radical, if we had x written, so the x stays as it is, right? And what we can do is minus 7 plus 4. And we know that 7 minus 4 would be 3, the sign of the greater number, and x comes over here. In algebra, we know this is done in this manner. So we would follow the same rule for the radicals. Because the radical is a 5, it's a prime number. It cannot be further broken down. So what we do is we subtract the coefficients. A coefficient is the number that is written before the radical or before the variable. And root 5 stays as it is. So what should be? 7 minus 4 was 3. The sign of the larger number comes. And root 5 stays as the radical, which is the answer to this question. So minus 3 root 5. Okay. Moving ahead, they're saying simplify. Sorry, they're asking us to simplify. Just a moment. Okay. And find the answer. Okay, they have an additional statement over here. Simplify and assume. Okay. Why are we assuming this? Because if the value of d was 0, then everything will become a 0, right? That's why we assume that d is greater than 0 or equals to 0, right? So for question number 6, we need to simplify this. 126 is not a perfect square number. So can we write this as radical 126 is multiplied by radical of d squared? Okay. I'll try this question with a little different concept. Okay. So let's see what are the prime factors of 126. 126 can be divided by 2. It comes out to be 63. And we know that 63 can be further broken down into 3 times 21, 3 times 7, and 7 times 1. This is prime factorization. Prime factorization means we break a larger number into the product of its prime factors. So 100, we know, so 126 can be written as 2 multiplied by 3 multiplied by 3 multiplied by 7. Okay. Or we can, or sorry, just a moment, please. We can say that in another way, we can say this can also be written as root 2 into root 3 squared into radical 7, right? Multiply by radical d squared. And we know that a radical can be cancelled out. A radical can be cancelled out with the square root. This becomes 3 multiplied by root 2 multiplied by root 7 multiply d. So we can say 3d multiplied by 2 multiplied by 7. That would be 3d radical 14. Okay, I'll try an alternate. I'll show you an alternate to this. Okay, so we'll look at an alternate way to do this question, which I was doing previously. Okay, so it would be your choice to pick either of these options. Okay, so what I do over here usually is I look at pairs, repetitions. Okay, so can we write this as radical d square means d multiplied by d. I said if we had a pair over here, the pair comes out and everything else stays inside the radical times. Do we have a pair over here? That means the pair comes out. So finally we can say, sorry, this was a 7, my mistake. This was 7 and 2, right? That means 3 multiplied by d would be 3d. And this is radical 14. This is your final answer, right? So this is just an alternate way. I was doing an alternate way to solve this question. So it's an alternate, right? And they both are exactly the same thing. But I would say is the first method that I'm doing is like making everything in a square radical. That would do a lot more steps on it, right? The easiest way is to see if there is a pair and the pair comes out, to see if there is a pair and the pair comes out of the radical, because it's a square root. A square root would mean 2 of the same variables or 2 of the same numbers inside the radical would cancel out the radical and they would move outside the radical. Okay, do we agree? So we are done with question number 6. Let's look at question number 7. Okay. In question number 7, what they are saying is simplify. Just a moment, please. Let me copy this. Okay. If this was question number 7, okay. And they're asking us to simplify this. Since 28 is not a prime number, we can do the prime factorization. Divided by 2, it's a 14. Divided by 2, it's a 7. And 7 times 1. So we can say 28 can be written as 2 multiplied by 2 multiplied by 7. Agreed? This was a W cubed. That means the variable is multiplied by itself 3 times. And we apply a radical on either sides. This shows that the values on the left side are equal to the values on the right hand side. They both are equal. Okay, let's try to look for pairs over here. Can we find a pair of 2's? Yes, we can, right? That means the 2 which is in a pair comes outside. Can we find any other pairs? Yes, we can find a pair for the variable, that is w. That means the w comes out as well. Now let's see what is left inside the radical. This 7 is left and this w is left, right? So can we say 7 multiplied by w is left inside? Therefore, the final answer is 2w radical 7w. This is our final answer because the w had an exponent of 3. That means there were 3 variables of w. If 2 moves, 2 of the variables, they go out, 1 is left inside the radical. Agreed? Okay. Do we agree? Any questions? Okay, good. Okay. They are saying if we have the question root 20, okay, under root 20, and we need to simplify under root 20. Question number 8. So under root 20 is exactly like, we need to do this question exactly as we did for 28, right? Because 28 was not a perfect square number. Similarly, 20 is not a perfect square number. Let's try to find the prime factor. Let's do the prime factorization. 20 can be divided by 2, we get a 10. 10 can be divided by 2, we get a 5. Since 5 is a prime number, it cannot be divided by anything else. So we do the prime factorization, through which we can say 20 must be equal to 2 multiplied by 2 is 4. 4 multiplied by 2 is 4 multiplied by 5 would be 20. That means 20 can be broken down into prime factors and written as 2 multiplied by 2 multiplied by 5. When we apply radical on either sides, we look for the pairs. Do we have any pair? Yes, we do have a pair of 2. That means since we have a pair of 2, the 2 comes out. And inside the radical, we are only left with 5. That means 2 radical 5 would be equals to radical 20. They would have the same answer. How can we check this? We write radical 20 in the calculator and it shows us 2 root 5. Okay? Moving ahead to the next question. So the next question states that simplify, just a moment please. It's okay, just a moment. It says subtract and give your answers in the simplest form. Question number 9. Okay, this is our question number 9. And what they want us to do is we need to subtract the variables which have radicals on it. It says minus 6 root 5 minus 5 root 5. If the question was given as minus 6x minus 5x, right? How are we supposed to do this? Since both of them had the same sign, they will be added. We know the rule, right? If in algebra they have the same signs, they're added together. 6 plus 5 is 11, and the variable comes as it is. The sign of the greater number is always carried forward. So this was the rule we follow in algebra. We follow the same rule for radicals. What we can say is, if this was 6 minus 6 radical 5 and minus 5 radical 5, right? So what we follow is, we follow the same rule. Minus 6 and minus 5 will be added. That becomes minus 11. And radical 5, because it was common to both the values, it stays as it is. And this is our final answer. Keeping the rule of algebra in our mind, we can simply directly simplify this. Okay? Do we agree? Any questions up till now? If there are any questions, do let me know. Okay, thank you. Let's move ahead and let's see. Okay. I'll do question number 10. Then I will try to change question number 10 to make it more difficult, okay? I'll just try to edit something in question number 10, and we'll try to create a difficult question. Okay. If I remove the subtract from here, I simply say simplify and write your answers in the simplest form. And the given question was this. Let's remove the negative signs for now. Okay. Let's try to see if this question was given to us. This is our question number 10. Okay. So the next question to this, I will try to make something else out of it, right? I'll try to make it difficult in the next question. So we know that they both have the same radicals. They both have the same radical, that is root 2, which is a prime number that cannot be further simplified. Agreed? Okay. So what happens next is, we know that the numbers 2 and 10 were there, right? So what we can do is, we can add the numbers 2 plus 10, and the radical 2 is multiplied by them. That becomes 2 plus 10 would be 12. Radical 2, and that is your final answer. Okay, but if I would try to make this question a little difficult, let's see if for question number 11 we change some values over here, and I say this is not radical 2 anymore, this becomes radical 20. Okay, so what we can see over here is both of these variables, right? Or maybe 1 minute. Rather than 20, let's make this for 8. Okay, let's make it 8 over here. Let's see if both the variables have a different radical. We see, right? We agree that they both have different radicals. That means if I say 2x, if I would say 2x plus 10y, they cannot be added, right? It cannot be, it would never be equal to 12xy. We know that for a fact, right? So what we can do always is, we need to have the same variable or we need to have the same radical. So looking at this question, what we can see is 2 is a prime factor, right? 2 is a prime number, but 8 is not a prime number. Can 8 be prime factorized? Any number inside a radical which is not a prime number can be reduced, right? So let's see. 8 to 4. 2 times 2 is 4, and 2 times 1. So we say that 8 can be written as 2 multiplied by 2 multiplied by 2. If we apply radical on either sides, can we see a pair of 2 over here? Yes, we can. That means under root radical 8 can be written as 2 and root 2. Agreed. So can we replace the value of roots radical 10 by, can I replace the value of radical 10 by this? So can I write 2 radical 2 plus 10, and the value for this radical 8 can I replace this by 2 root 2? Because we just proved over here that radical 8 would be equal to 2 radical 2. Agreed? And we know that these two numbers are multiplying. So this finally becomes 2 radical 2 plus 2 times 10 is 20, right? Radical 2. So now what we have is, we have the same variable. The variables are same, right? Radical 2. That means we can add 2 plus 20 and radical 2 stays as it is, finally giving us the answer 22 radical 2. Okay. In this case, we were able to reduce 8 because 8 is not a prime number. So we did the prime factorization to reduce the value of 8 and then we simplified it. Agreed? Okay, we'll try some more questions. Let's look at the next question. Okay. For the next question, I will try to create a similar question, okay? Once we're done with the next. Okay, if this question is given to us, okay, for question number 12, let's do question number 12 first. Then we'll see how it can be done by change of radicals. So this is question number 12. Let's have a look at question number 12. Question number 12 says 5 radical 3 plus 9 radical 3, okay? I'll just put it in a box so that we don't confuse the workings. Okay. We know that they both have the same radical, radical 3 and radical 3, and they are being added together over here. So simply we say 5 is added to 9 and the variable that is radical 3 because it is constant throughout. This is the distributive property, right? And we can say 5 plus 9 is 14. Radical 3 is our final answer. Okay. But if I would change the question and I would say, give your answer in the simplified form for question number 13. I will try to make question number 12 and alternate to that. Okay. If I would say the question number 12 is now given as, just a moment, please. If this was question number 12, it's now given as 12 over here. Okay. So both the radicals are different, right? The first one was 5 root 3 plus 9 root 12. And we know that 9 and 5 can be added if and only if these two values were same. But they're not equal right now. So what we can look at is 3 is a prime number. Radical 3 is a prime. It cannot be further broken down. But can 12 be broken down? Yes, 12 can be factorized. So we try prime factorization for 12. Times 2 is 6, times 2 is 3, and times 3 is 1. Can 12 be written as 2 multiplied by 2 multiplied by 3? If we apply radical on either sides, under root on both the sides, we see a pair of 2. That means under root of 12 would come out to be equal to, 2 is common. That becomes 2 under root 3. So in place of under root 12, can we write 2 under root 3? I'll just copy paste. Okay. For this, we can say, if this was written as it is, in place of this, can we write 2 under root 3? And since these two numbers are being multiplied together, we can write this as 5 radical 3 or 5 under root 3 plus 9 times 2 is 18, and it again has radical 3. Do they have the same variable or the same radical? They have the same, right? Therefore, they can be simplified. How would we simplify? We simply do distributive property. We say 5 plus 18 and radical 3 stays as it is. That should be equals to 5 plus 18 is 23 radical 3. Okay, and that is your final answer. Okay, so what we did was we consider a question with the same radicals, and we consider a question with different radicals. If there are different radicals and if it's not a prime number, it can be broken down. And if the radicals come out to be same, then it can be simply simplified, right? Okay. Okay, just one more question and then we will do some questions from the test, okay? Okay, let's do one more, because explanation I think is more important, and if we understand it, then the questions would be easy, okay? I just want to do this because it has 50 r to the power 8, right? For question number 14, it says simplify 150 r exponent 8. So whenever the exponent is even, it's very convenient for us. Why? 150. Let's do the prime factorization for 150 first. 150 is an even number. That becomes 75. 75 cannot be broken down by down by 2, right? But it can be broken down by 5. So we can write 5 times 15, 5 times 3, and 3 times 1. So 150 can be written as 2 multiplied by 3 multiplied by 5 multiplied by 5. If we apply a radical on either side, we have a pair of 5. That means radical of 150 can be written as 5 radical 2 multiplied by 3. And a radical of 2 multiplied by 3 is radical 6. So if we break this question, if I say 150 multiplied by, how many exponents were there? 8, 2, 3, 4, 6. There were 8 exponent on r. That means there would be 8 values of r. 150 can be written as 5 root 6 multiply. How many values pairs of r are here? We have 4 pairs, right? That means r multiplied by r multiplied by r multiplied by r. That means the final answer comes out to be 5 root 6, 5 radical 6, r to the exponent 4. And that is our final answer. Okay? Do we agree? Let's try a question, at least one question, okay? So just a moment, please. I need to go back. I am grade 10. That was chapter 1, lesson number 4. Let's do the test. A question or two, right, please? So that we have an understanding. Okay, let's do this quickly. Add and write your answers in the simplest form. I'll just copy the question, just a moment. So the first question from the test says, okay, question number 1 from the test. I'm just copying it over here. Can I have the answer? Which option should be correct? Option A or option B? Meanwhile, I'll just simply give the heading. This was the test. And we have these 2 questions. What should be the answer? Because they both have the same radicals, right? And the sign of the greater number is always used. So what should be the answer? Can anyone answer? Can Can anyone give me the answer to this question? For question number 2, it says this. Okay, let's do both of these questions. This would be our question number 2. The question number 1 was adding, and the question number 2 is subtraction. Okay, this is option A, option B. Yes, thank you. Since radical 5 was common, we simply do minus 7 plus 4. We subtract, that is 3, and the sign of the greater number comes. Yes, thank you. What about the next question? Question number 2. What should be the answer for question number 2? Yes, thank you. It's correct. Option number B. Because both of them were negative, and when both the numbers are negative, they are added together, right? Yes, option B is the correct answer. That becomes minus 11 root 5. Okay. So please do try the remaining questions. Okay. They're just 14 questions and very similar questions. Okay. So if there is anything you need to revise, you go through the lesson. All the basic concepts have been covered over here, and best of luck. Okay. Thank you so much. Have a nice day. Best of luck. Take care. Bye.